So I'm Dr. Susan Ip-Jewell. I'm the CEO of HoloTRIAGE, and HoloTRIAGE is a company in the United States that is developing capabilities and technology to be able to support isolated crews or teams in what we call dangerous and remote environments. So that includes space. So HoloTRIAGE is really the ability for us to train using these technologies for what we call, in remote, isolated environments, and also in a clinical setting, right? For first responders, for medical students, and definitely for astronauts. So basically, as I said, right now the problem is that here, when we train to do basic life support or advanced life support, or just basic training in medical skills, it's very limited, right? And so for us, we're trying to escalate to provide the capability for us to train with these technologies, and to also reduce the cost of the training. So in this case, we developed HoloTRIAGE with the convergence of several technologies, not only spatial computing, but the ability to also bring in haptics. So haptics are biosensors that are incorporated into whether the gloves or to the wearable that you're wearing. And now you'll be able to also feel and touch, remotely as well. So that is actually to be able to enhance the ability for us to do these training modules. So, as I said, this is actually potentially a technology that's going to change the way that we train in the medical field, but also how we train astronauts, or when one day we have an injury on a planet's surface, right? And how do you go and do immediate intervention for life emergency support, right? You're not going to now drive to that injury site, with a search and rescue team, and be able to then say, well, now we're going to do the intervention. So this is actually going to give us that ability. Now I'm going to show you a video of some of the what we call, the modules that we developed. And in this case, we developed three modules, training modules. One is how do you stop a bleed. Second one is an unconscious patient, and the third one is a choking child. Okay, so here we go. So in this case, you can see, this is a bleed, hemorrhaging. So and then here is the unconscious patients, and then over there is a child that's choking. So you can see the hand. That's the person actually, being able to, with the HoloLens, be able to interact real time. And when you press, so for example, taking the pulse on the neck, then it will show you the instructions, how to do it, and then what's the next step. In this case, this is a choking child. See the hands, okay, you're going to slap the child in the back and try to see if you dislodge the obstruction. If not, you're going to do the handling, the maneuver to dislodge. And then in this case, now you're going to, of course, stop the bleed, and we're trying to put, a tourniquet. So really, it's the step-by-step, and this is our TRL 3, or for Technology Readiness Level 3, and we're moving on to be able to increase the library including basic life support, advanced life support. So here you can see, actually, applying the tourniquet. So this is a training module, so you can see its advantage for remote teams, for people who are unskilled, to learn some of the basic medical technology. So we'll move on. So in this case, you can see some of the benefits. Obviously, it's going to change the paradigm of how you train in remote settings. It's obviously going to reduce costs of training, because now you don't need to, currently the model is to be able to have to get real mannequins out in the training area, and then you're going to have experts or trainers, and that's a lot of time and energy and cost. So using this technology is going to be able to remove all that and be able to be more efficient, more cost effective, and you can scale up and train, much faster and larger groups of people. And of course, for astronauts, and one day when we're actually on a planet's surface, this is a technology, because not only that, the ability for us to do remote, and you're able to what we call teleport, maybe sounds like science fiction for some people, but this technology allows you to be able to teleport as a humanoid avatar, and to be able to do real-time intervention or real-time interaction with the crew at that, or the team at that location. So this really is an exciting time for technology, this type of technology, but the problem is, and well, it's not a problem, the challenge is, how do you integrate or converge all these technologies? Of course, at this point, we're also integrating, and I like that question previously about AI and artificial intelligence, where you would be able to incorporate that into the software platform and to be able to increase the efficiency and the learning, and the AI itself eventually will be able to be the trainer versus a real trainer, because it's been fed all this data, all the protocols, so it can actually be an effective trainer, replace the trainer, or augment the trainer. So, I'm going to do that. So, obviously, this product, when we develop a technology, we have to ask ourselves, does it also have commercial viability? Can the product be used in other sectors? So, of course, we're focusing in space right now, because this is a space conference, but the idea for us is we can also apply it here on Earth for disaster areas, search and rescue, for humanitarian rescue, and of course, in the battlefield, right? Because you don't want to send in people, medics, to a dangerous area, right? So this would actually be able to solve that problem. You don't want to, put somebody else in danger to be able to rescue an injured patient or victim. So this is very detailed of our timeline projection, how we're going to create this product. As I said, we're already at TRL3, and we are now going to be testing this technology, this software product platform in an analog astronaut missions. And one is going to deploy in 2023 to Everest Space Camp as a full medical team, analog astronaut team, at very high altitudes, and be able to test the technology, the user feedback, and how can we enhance and optimize this platform.
Okay.
Hello, and thank you for sharing that with us. I am just curious if there's any data validating if this training system is as effective, if not better, than traditional services.
Traditional methods?
Yes.
Well, because the technology and the concept, the vision of this technology for this particular application is still at the early stage. We don't have enough data, and that's where we're moving forward, to be able to collect the data, to validate and prove a concept for this particular application. But I do feel like, and in the clinical setting, the use of XR, or spatial computing technology, is already there. So it's not like it's a new, science fiction concept. But to be able to really gather the data, and to be able to prove that it's more effective or as effective as current protocols, we still don't know yet. Evaluation of the technology and the real benefits of improving the state of the art of how we currently train, and also how do we train astronauts, one day remotely when we don't have communication contact, because right now there's a 20-minute delay on Mars. How do you overcome that challenge? So hopefully with these technologies, we can address that challenge, and it can have the potential to solve that problem.